Thus far, we've learned about function handles and anonymous functions. Function handles were a new and important construct, allowing us to store references to functions in Matlab variables. Anonymous functions, on the other hand, were really more of a convenience feature, primarily used in two ways: to write one-line mathematical functions without editing files, and to take a very general existing function and create many special cases of it by setting certain combinations of input arguments to pre-specified values. Subfunctions are in the same spirit as anonymous functions, a convenience feature that in some circumstances allows us to structure our code in a more readable and organized manner. So what are subfunctions? When we learned mfile functions in the previous module, we were writing one function per mfile. It turns out it's okay to have two or even more functions. The first function I'll call the primary function. That's the function whose name is the same as the file name. The second, third, and so on are called subfunctions. They all use the same syntax for a function declaration line. The subfunction names can be anything different than the function name. Conventionally, they usually begin with the word local in caps. It's a little easier to search for subfunctions if they all begin with the word local. They give you the convenience of functions, that is, local variables within a function, and communication to the caller only through input and output arguments, but without the extra mfiles. So, like a function, all variables defined in a subfunction are local to that. Input arguments and output arguments are used to pass copies of variables in and out of the subfunction, just like we learned about for functions. One thing that's important, though, is that the subfunctions of a file, the second function and beyond, are only visible to, in other words callable by, the primary function in the same file, as well as any subfunctions in the same file. However, subfunctions can be called by their function handle. The function handle can be accessed by the primary function and passed back to the caller. So actually, once the caller has that function handle, the subfunction can really be called from anywhere. This is a busy slide, and there's a handful of things to remember, but the most important point is that subfunctions will give us the convenience of functions without extra mfiles. Let's look at a conceptual instance of this. Here's an example without subfunctions. There's a main function, myFunction, which calls three utility functions, utility 1, utility 2, and utility 3. They're contained in mfiles themselves. There's utility 1, utility 2, and utility 3. Likely, these were written in three separate files to make myFunction a more readable function. Now it only consists of a function declaration line and three simple lines. It's not cluttered by the details of the actual instructions for utility 1, utility 2, or utility 3, any one of which might be very complicated. The ability to move the instructions for utility 1 into a file called utility 1, and then only call that file from myFunction, and the same thing for utility 2 and utility 3, is really one of the main conveniences of functions. What does the folder look like? Well, the folder has myfunction.m in it, as well as utility 1, utility 2, and utility 3, and possibly there are even some more. So there's an example without subfunctions. MyFunction is very simple because we've used functions, and the complexity of the functions is hidden in their own individual mfiles. What does this example look like with subfunctions? MyFunction.m has the same 4 lines of code. Notice, though, I've changed the name of the functions from utility to local utility, and in fact, these functions are in the same file. There's a function declaration line for local utility 1, a function declaration line for local utility 2, and another function declaration line for local utility 3. The code that would have been found in the M files on the previous slide is now simply found below each of these function declaration lines. Remember that all variables in a subfunction are local to it. Therefore, it's okay to have variables named the same across these subfunctions. There's no clashing. The variables are all separate. This gives us the convenience of functions. Notice the simplicity of the myFunction code itself. It's the same three lines, a call to utility 1, utility 2, and utility 3. But without the extra M files. In this case, the folder looks like this. There's simply no other files, and all the functionality is contained within my function. The drawback is that no other programs can call local utility 1 through 3. Those functions are subfunctions of my function and only visible to my function and to each other. Let's do an example. We'll talk through the example in PowerPoint and then actually do it in Matlab. Here's the contents of a file called subx.m. The primary function is the first function in the file, also named subx. It has 2 input arguments and 2 output arguments. On the second line, it calls a subfunction called local function 1, passing it 2 arguments and ultimately assigning to a variable a in the primary function. On the third line, it retrieves the function handle of the subfunction and stores that in a variable h. The subfunction, called local function 1, is very simple, just computing the square root of the product of the 2 input arguments. Now let's see how execution would work from, for example, the Matlab workspace. Assign 9 to a variable m, assign 4 to a variable p, and make the call to subx. Let's trace through what happens. 9 and 4 get passed as copies to b and c. On the second line, there's a call to local function, passing the numbers 9 and 4. That will return the square root of 36, which is 6, which is subsequently added to 9. Therefore, a takes on the value 15. Then, h is a function handle to the subfunction, and that's returned. So on return, r will be the number 15, and k should be a function handle. Let's check that out. R is the number 15. Rather than just look at k, let's see if k works as a function handle. It's a handle to a function that accepts 2 input arguments and returns the square root of their product. Therefore, k on 2, 8 should return the square root of 16, which is 4. And indeed, it does. So the message here is that every subfunction can be accessed from anywhere, but you do need a valid handle to the function. Can the subfunction be executed by name from outside the file in which it lives? The answer is no. In this case, trying to execute local function 1 from the command window results in an error saying that local function 1 is undefined. We knew this to be the case because subfunctions are only visible from within the functions that reside in the same file that they reside in. Let's quick try this in Matlab for real. Open the editor. Just make sure subx is the same as what was on the slides. It is, with a few comments. Now let's try the sequence of commands from the slides. M equals 9, P equals 4, and then a call to subx. R is 15, and the class of K is function handle, and K of 2, 8 is 4. If we try to call local function on, for instance, 2, 4, we find that it is undefined.